Okay. Okay. I gotta go and mute the printer stream. Not that it's making much noise anyway. Gotta love the tripod setup here. I got a cell phone taped to a chair. Okay, so here's the deal. If anybody has any questions at all, um, if you toss them in now, I will try to cover them during the stream. Um, yeah, we'll make all this work. Hey, Chris. Yes, I will go and do that right now. Let me figure out how to do that on YouTube. Yeah, so it's a little bit there's a little bit extra going on with it as far as the printer goes. I'll get more into it a little bit later, but we have an automatic part ejector system which actually goes on it, and basically when it's done printing your object, it kicks it out and then it starts out the next object. Yeah, if it was last year at the Bay Area Maker Fair, that was us. And we had two different machines. We had the smaller model and this larger one. Unless you're thinking it might have been something else. As far as 3D printers go, the Rostock Max is really solid. Um, we've been really happy with how they've worked out. Yeah, so the blades sweeping across the build plate, unfortunately, that's the bulldozer method, and that got locked down by Envy bots, if I remember correctly. And they've gotten purchased by a larger CNC conglomerate, and they have all that technology locked up with certain patents. Uh, our ejector, while possibly similar, is it doesn't violate that patent, um, and we have gone through the effort of protecting the IP for it, but we're not evil like let's just say Stratasys or whatever, when they went and they locked down their auto ejector technology and stuff like that. Yeah, if there's any 3D printer manufacturers that want to go and integrate the auto ejector that we've gone through the effort of doing that all on, we are very happy to go and work out something reasonable too for getting it on their machines. And also, anybody who has a 3D printer with an automatic ejection system in general, um, if your printer supports that, you can hook it up to our cloud software and use our cloud software for running your 3D printer. When we get into the demonstration, I can talk a little bit about how that all works and how you would get set up. But the nice thing is that with our cloud software, you're able to assign cost to materials, and in a shared environment like a library or a makerspace, somebody simply puts in their credit card details, and their card gets billed when the item gets manufactured. And you can have optional moderation and stuff like that, which makes it really easy to manage 3D printers as an actual shared resource. Um, this 3D printer we use over at the Spark Makerspace, and it's been working out pretty well. We've been running this one for close to a year now. We've gone through a lot of different iterations on automatic part removal, but the biggest thing is that people don't touch the printer. They just hang out, and they can just print from home and then come down and pick it up. Right now, the makerspace is closed because of the whole COVID-19 thing, but one of our printers is over at one of the local libraries, and they've been printing out a lot of stuff not directly related to, like, not directly making masks and whatnot, but they've been making templates and jigs for other people who are making masks. So that's something that's really cool that they've been doing. And the nice thing is that nobody has to enter the library to get their parts over there. I think the librarians, what they do is they take the parts and they put them outside so that people can pick them up. But the thing can run 24/7 overnight. It just does its business. And when you come in, you got a pile of parts sitting there. You can just go and scoop them up, put them outside, or do whatever you need to do. It's really designed so that it's self-service. Uh, yeah. Once we get into the once we get into the actual stream for the 12:30 stream, it's going to be rather interesting. I'll take everybody through the browser-based workflow, which includes being able to design your parts in the web browser and then going directly to the 3D printer in just a couple of steps. What I have to do is I have to watch, and I have to catch this print. Because basically, when this print is done, I'm going to turn off the printer just so that it's still sitting on the build plate, so that when I start the next one, we see this one eject. I'm going to just switch over to the feed right now of the printer, and shoot, I missed the auto eject sequence. Okay, so just so that everybody knows, I just moved the print that finished back onto the build plate, because when I go to start up the next job, I wanted to go and show the full auto eject sequence. So Yeah, there's no funny business. It's just I missed it, so I wasn't able to switch off the printer before it did the eject. Okay. Let's see about sharing my screen just to make sure that all works. Whoa. Okay. There we are. So, just so that everybody knows, I am running entirely on a Chromebook. So, this whole demo is going to take place entirely inside a web browser, which is going to be kind of fun. You'll be able to see how you can go from designing an actual part in your web browser to directly getting it manufactured on a 3D printer, all without anybody ever really touching the printer. The printer is going to be basically operating entirely autonomously. And when I go through and I request my print, it's going to go into the queue. So if there were other parts in the queue, um, my part would wait until those are all done. Um, let's see here. Yeah, I'm just going through and seeing how well this is all going to go because the streaming software here actually can be a bit slow and slow things down. That was just a little part I made earlier. Uh, okay, I'm going to stop the screen share. Okay. Now, if anybody's going to have any questions, I do encourage you to go and put them into the chat. I'll be able to answer them. And at the end of the session, I'll probably stick around for a while to go through and answer anybody's questions. And potentially, if you wanted to even hop on the stream here, I could send out a StreamYard link if you wanted to hop on and really ask some interesting questions. So you gotta love that automatic leveling system on the Rostock Max. It really does a good job of making it so that you can print on a surface that's moved slightly from the last time you printed. So the interesting thing about the auto leveling on the Rostock Max these days is the head itself detects the flex of the PCB. Basically the entire effector plate is a PCB, and it touches the nozzle to the bed, and it flexes that PCB that is the effector plate, and that's how you can get the auto leveling. And it works really, really well. Um, that and they have the Duet control boards in them, so they're really nice. Okay, so we got probably about 15 minutes until we start actually doing the demo. But if you're going to have any questions, feel free to put them up during the demo. If I don't get to it actually during the demo, I'm going to be sticking around later afterwards to answer anybody's questions, and possibly even if you wanted to hop on the stream and ask or just talk about this kind of stuff, we can set that up. I could send you a StreamYard link if you really are interested in doing something like that. So we got about 15 minutes until the stream starts, and we'll go through a complete workflow where I'll design some kind of a knob or something. One of the most common things that we get that people are printing, besides all the little action figures and just like the little weird pop culture kind of stuff, is knobs. A lot of people need to replace knobs, whether it's for their dryer or for an antique radio, whatever it is. A lot of people print knobs. So that's what I'm going to do a little demo of real quick when I get started here. And let's see here. Okay. I'm just going to be clicking around here, doing some stuff, setting up for just doing a little practicing before the demo. This right here is actually the web browser based CAD that we have, which is really, really awesome. So I'm just going to go through and I'm just practicing making a little knob here, just making sure I don't run into any hiccups during the demo. But it's going to be pretty interesting. Let's see. Let's see here. Just going to set these to be equal radius. I'll tell this one that it should be vertical. I'll also tell this one that it should be vertical. Let's see here. And we can do something here. I'll set these guys to be, well, you know what? I'm just going to do this. I'll just do a dimension from there, and we'll do, I don't know, 5 millimeters. And we'll do a dimension from there. Set that up as 5 millimeters. You know what? I actually don't like that number. So I'm going to set that up as 3 millimeters. We'll set this one. Did I not do this one? I did that one. Where is that distance? Distance between two. Distance. No. Whatever. There we are. We got something. And I'm just going to go and extrude that. Let's extrude that maybe 15 millimeters. How about this? I can go and fillet these guys off. Let's set that for 10 millimeters. Let's set that for 5. There we are. So we're making a little knob here. And I'm just going to do one more sketch here. I'm going to just go and put a hole in so that we can fit this on something. And I'm going to set that radius to 5 millimeters. I'm going to set that to, let's just say, maybe 2 millimeters radius. There we are. So that's going to be a 4 millimeter hole that gets put in there. And I'm going to cut that out. There we are. Got a little knob there. And Get my info. I can reorient it if I want. Look at my G code. Okay. Got a nice little G code preview there. Okay. I think I'm going to be good to do this. Okay, we got probably about 8 minutes until the demo actually starts here. In the meantime, I'm going to kind of give you a little primer as to what we're going to be going over. First off, we're going to go and design a part inside our web browser. It's going to be using a parametric 3D modeler. That's part of our cloud platform. Once the part's designed, we're going to send it to the print queue, and you'll be able to see the printer go and start printing that out. Right now, I have something already printing, which I may or may not kill that print before I have to start the next one, because we want to show an ejection sequence. The 3D printer that we're using to demo this today is going to automatically eject the 3D print. So that's kind of cool. And basically, it means nobody has to touch the 3D printer. They just pick up their part and they're able to leave. So that's basically the workflow that we're going to show off today. We'll talk a little bit about some of the features of the platform as far as for makerspaces and libraries. Makerspaces and libraries need to be able to kind of manage their printers and make it so that they're accessible to larger groups of people. So the software that we have really enables large groups to share a 3D printing resource and queue their prints and then come down after they've been automatically ejected. So we got about 5 minutes until the stream starts, where I'll go through a full demo of designing a part in the web browser, requesting that it get manufactured, and having it so that it automatically starts 3D printing on the 3D printer over here. And the 3D printer is going to do the automatic part ejection, remove the part automatically. So there's no bed scraping, there's no putty knives or the things that you have to go and scrape it off the bed with. So this is going to be kind of a fun demo with the complete workflow. If anybody's got any questions during the demo, please feel free to toss them into the chat. And if I don't hit on it during the demo, if you stick around afterwards, I'll be live streaming for a little while to be able to answer people's questions. And hopefully, if you have a 3D printer which has automatic ejection, or even just regular 3D printers, I can talk to you about how you can add your printer to the network and make it so that your users can print to it. Show you maybe a little bit about how you could set up billing if you wanted, and some other stuff like that. Let me see here. I don't know whether, let me see if the chat is actually working. So StreamYard's pretty interesting. I've hopped on a couple of streams in the past that people have hosted using it, but this is my first time really hosting a stream using it, so a little bit of a learning curve here. Okay, we got a couple more minutes, and then the stream is going to officially start here. Uh, Okay. Just going to take a peek here at the print. I'm hoping I have this timed just right so that I can show this one getting ejected and the next print starting after I do the modeling demo, and it should be interesting. I'm crossing my fingers that I got the timing right here. Hello. Okay, so we're going to get the stream started here. Today, what I'm going to go over is how we're using AutoDrop 3D, and we're automating the 3D printing workflow at our local makerspace. This is going to show off a web-based 3D modeling tool. It's going to show off the queuing and print farm management software. And it's also going to show off the automatic part ejection hardware, which basically it'll remove the print when it's done printing and allow the machines to run continuously unattended. Right now, during COVID-19, it's difficult for people to actually gain physical access to these kinds of things. So what we're doing is we're making it so that these things are still accessible. People can access them via their web browser, and it's really nice as far as being able to manage even just one printer or a fleet of them. So without doing too much more, I'm going to get the stream started. And basically, if you have any questions and whatnot, please go ahead and toss them into the chat. If I don't answer it directly during the demo, what I can do is I'll stick around afterwards and be able to answer any questions then. So what I'm going to do is I'm going to start sharing my screen. Okay, here we are. So right here, this is the AutoDrop 3D platform. Basically, I've just logged in and it's brought me over to my parts page. So this is just a bunch of parts that I've either uploaded or designed in the system. You can upload any STL file that you want and just drag and drop it in. I'm going to go and actually design a brand new part today. Now, just so that you know, right now I am running entirely on a Chromebook. And this entire demo is taking place on a Chromebook. So there's nothing for me to install. I'm just running this all via a web browser. Now, the first thing I'm going to do is I just created a brand new part. And it brought me into this parts page, or this part page. And I'm going to tell it the modeling method I'm going to use is JSketcher. Now, that's going to be the 3D parametric CAD software that we're using to design this part. So now that I have it set to JSketcher, I can come over here to Editor. And what this is going to do is start up a blank, empty CAD session. I'm just going to go and hide this, this bar here a little bit so I have a little more space. And I'm going to start out by drawing a plane. And what this does is it just creates a plane out in 3D space. I could do some more with it, but I'm just starting a sketch here. If I click on it, it becomes highlighted. And now I can sketch on that plane. And I'm just going to start drawing something. So I'm going to draw a circle. And I'm going to set the radius on that. Let's just say I'm going to set it to 15 millimeters. So there we are. I've drawn a circle, and basically I've set the radius on that circle to 15 millimeters. I'm going to finish my sketch by hitting the little check up here, and there's my sketch in 3D space. Now, if I go in here, I can do an extrude on that sketch, and I'm going to set my extrude length to 5 because we're going to make a tiny little knob here, basically. One of the most common things that people go and print, besides all the little action figures and the figurines and whatnot, is our knobs. This is like one of the most common things that you'll see people printing. So this is an easy demo to kind of go through and show a workflow for this CAD software. So now that I have my my little extruded disc here, what I can do is I can pick on the surface of it that I want to go and sketch on, and I'm going to go and sketch a little bit more here. So I'm going to add in a portion of the knob so that you can grab it and rotate it. So what I'm going to do is I'm going to draw a couple of line segments here. And I'm going to draw in a couple of arcs. Okay. So the software that we're using is actually a parametric CAD software. And this is all running right inside your web browser. And this is part of the platform. It allows you to get in there and start designing things immediately. And part of this is I can go and do constraints on my geometry. So for example, if I highlight these 2 points by holding down the Shift button and clicking them, I can tell them that they are the same point. So right here, I'm going to add in the coincident constraint. And now the center point of this arc is right there. And I'm going to do the same thing here. I'm going to go and pick those 2 points there, and I'm going to constrain the center point of that arc to be there. I'm also going to set these arcs to have the same radius. I'm going to do the same thing here. Just set them to have equal radius. And we already have these two lines here. So I'm going to just go and constrain these guys so that they have their endpoints lining up like this. And I'm going to do the same thing over here. Just going to go and do these kinds of constraints. And now, I can click and drag on it and notice how the geometry all updates. I'm just going to set up a couple more little constraints here. So I'm going to set up a distance here. And I'm going to set that maybe to, let's just say 5 millimeters. And I'm going to do the same thing here. I'm going to set up a distance here. And I'm going to set that up as 5 millimeters. So now I have this. Oh, you know what? I need to set this one to be vertical. Oh, well, I guess I don't want to do that. You know what? No, I'll just go with it. I'm going to set this one up to be vertical also. So now those are all constrained fully. I can't move them anymore. They are where they're at, and I have them all dimensioned here. If I wanted to update one of these dimensions, let's just say I wanted to go and modify my distance from here to here, I could see my distance constraint down here, and I could set this to something else, like let's just say 4 millimeters, and it would update. And I could basically go back through and edit anything that's in here just by updating some values. So now that I have that done, I'm going to hit this little check here to finish my sketch. And what I can do is extrude. And when I extrude, I can set the value on the length of the extrude. So I'm going to set that to 15. There we are. And I think I'm good with that. I'll hit OK. And now you can see that we have this 3D knob looking thing starting to take shape. Now, you know what? I want to round these edges here. So I'm going to go and pick those edges and put in a fillet here. And I'm going to set that fillet radius up to being 5 millimeters. Oh, looks like I got somebody coming in here, so I'm going to have to go and put my mask on. Hey, Brian. Hey, doing the stream.
All right.
Okay.
So are you talking to people?
Yeah.
Through that?
Yeah, it's through the computer here.
Oh, you're talking.
Mm-hmm.
Okay. All right. Cool.
Okay. So yeah, basically there we are. We have a knob. I've added in some fillets on the edge of it. Now I guess the last thing I need is a hole in there to go and put this onto something. We'll go take this off now. He's out of here. And I'm going to go and sketch on here. So, you know what? I'm going to go and put in the stuff I need for this knob. So I need an arc. And I'm going to go and constrain those 2 points there and set it up so that that is coincident with the center. I'm going to go and adjust this a little bit and draw a line here. So basically what we're doing here is we're going to set up the locking feature on, yep, I don't need that. We're going to set up the locking feature on here. So this is going to be the flat that it's going to lock against the shaft. And what I'm going to do is I'm going to just set a length on that here in a second. So first off, I'm going to set a radius here. My radius is going to be 2 millimeters. And I'm going to set a distance here from the center, which will be, let's just say 1.5 millimeters. So now I've modeled what my hole is going to be in here. And I'm going to go and cut that out. Oop, I got the wrong thing selected. There we are. I'm going to go and cut that out. And now I have a 3D part that is basically finished. So what I can do at this point is save my part. and go back over to my part details tab, it's going to tell us about how long it's going to take. This is an estimate. It's kind of a generic estimate. It's going to tell us how much material it's going to use to print that part, and it tells me how big my part is. Now, it's oriented in the way that I like to have this part printed, with the flat part down that you're not going to see. But if for some reason I needed to reorient it, I can enter a value here in one of these rotation fields and hit save, and you can see how the part rotates. So you're able to get kind of a preview of the orientation of your part when it's going to print. If I come over here to the G-code preview, this shows me a generic slicing profile result of the slicing. And what that does is it allows me to see whether there was any problems with the slicing. So a lot of times, if you're importing parts from other CAD packages and some 3D modeling software, a lot of times you'll have problems with the 3D model. Oh, and I'm going to go and switch over to the other stream here. Hold on. So the eject. So what we saw right there, I didn't quite have it timed right, but basically the printer automatically ejected the last part it was printing, and now it's going into an idle state where it's going to wait for the next job, which we're actually going to give it now. So yeah, I switched my tab so it didn't finish rendering here. But basically what this is this is going to be your G-code, a generic sliced set of G-code, so you can diagnose and see whether there's any problems with your 3D model. With the CAD software that we have built in, there's not really much of a risk of having an issue with the STL file, but this right here would allow you to see those kinds of things. Okay, so I'm going to go back over here to part details. And what I can do is I can tell it to create an order. And I can pick my destination for this. So I'm going to pick my local makerspace that I'm part of. And I'm going to hit create order. Now, when it creates the order, it goes and it shows you how much this is going to cost. Now, because I'm a member of my local makerspace, the cost to me on this particular part is going to be 0. But basically, your makerspace can set prices on different materials if they want to, and they can set up kind of their process the way they want. And the billing can be handled all automatically through the platform. So at this point, what I'm going to do is I'm going to hit approve order. And this basically means, okay, I'm cool with all this stuff. I want it to go and get made. So I'm going to go and hit approve order. It says, are you sure? I'm going to say, yeah. And now I am going to go back over to the printer, which we're going to see start up. Oh, hold on. So right there, we can see the printer going through its automatic ejection sequence. And basically, it's sliding the build plate forward underneath a stationary blade where it peels the item off. You see that there's a landing area in front of the printer. That landing area is where the parts go and accumulate. So basically, what I can do is just go and pick up those parts off the landing area, and they are ready to be used. So before is the audio still there? Did I lose the audio? Can anybody hear me? Is the audio still working? I don't have another device here. I'm using my cell phone to do the stream of the printer. So, okay. So basically, at this point, the printer is doing an automatic level sequence where it is simply testing a bunch of points on the bed before it does its next print. And it's going to start printing automatically here. Okay. So before the stream started, earlier I designed a knob that wasn't quite as good. This one was just something that was kind of junky for me to just test how long it was going to take. I didn't put any of the fillets in or anything cool like that. But basically, I was able to go and just order that via the web browser and go and actually find it over here when it was done. I also received a notification. I'm going to share my screen here again. There we are. I received a notification in the browser that my print completed along with a picture. And you can see I printed out that one there. I printed out this one. So I've done some prints here, and there's probably a whole bunch of other ones. I'm actually going to, let's see, clear out my notifications because there is an awful lot of notifications there. Okay, so at this point, I'll take you through a little bit of printer management and how that's done using this platform. If I go over here to my organization, there's some stuff which I have access to. I'm not going to go into the users area because this is actually actually I can go into my users area, but normally you'd be able to go and set up permissions for people. You can set up who's an admin, who's not an admin, who can cancel other people's prints and such. Right here, this is a listing of printers. So you can see when they were last online or when they were offline. A lot of these, I had these all set up for different machines that we were testing in-house. And some of them have either been delivered to customers and are on their own platform now, or like this one right here. This one's online, sitting at my house doing something. Basically, you can go into each printer and configure it. You can set your material, your machine type, your start and end G code, your limits for the size of the bed, and there's a lot of other kind of options that you have in there. We have our CAM profiles, and these are basically the Cura slicing profiles for the slicing. And basically, you fill that in with all the settings for your printer, and you're able to use that, and it automatically slices for the printer when you send an object into the queue. You can actually have a whole bunch of different printers, and the jobs will get routed to each printer based on the size of the printer and whether or not they've specified a specific material, or if they have any material selected, it'll just go to whatever printer is available. Under our locations, you're able to go and set up some stuff. So you're able to set up your location profile and address. and you're able to add in your listing of materials that can be used on the 3D printers, and you can set your pricing on those. If we go and look at my parts again, we'll just take this through the workflow real quick of doing an order. We already did this earlier, but I want to order an assembly of parts. So let's just say I got 2 or 3 parts that I want to go and kind of group together and send to the machine, or send to the queue all at the same time. I can create a new part here, and I'm going to call this assembly. And instead of this being a 3D print, I'm going to call it an assembly. And I'm going to save that real quick. So now I get this bill of materials tab, and I can add in some parts into my bill of materials. So I'm going to add that knob. Maybe I want to add this bracket. And I'm going to add something else. Let's see. I'm going to add this fun, lovable boat. So these are all now in this assembly. And if I go back over to my part details, I can hit create order. And when I create my order, of course, I could specify the quantity of this that I wanted. But the idea is now my order is created, and it has all of these objects in that order. So now if I go and I hit approve, these guys are now all waiting in the queue to get printed. Now, if I go over to my queue, so these are all of the jobs that I have, and you can see that some of them are marked completed. This one is for an order that I never approved. But the rest of these are things that are waiting in the queue. And you can see right here, this is the part that's printing right now. I got a live picture from the printer showing me that part is printing. And it shows me a progress bar on it. And if I refresh here, we can see that that progress bar moves. So as my prints get completed, that progress bar will move, and I'll get a notification actually here in the browser that it was done printing. Rickroll somebody with a 3D QR code. Theoretically, you could print out a bunch of Rick Astleys on here, provided you really wanted to do that. And if your makerspace had credit card charging turned on, it would get charged automatically for all the Rick Astleys you wanted to print. Okay. The egg butler? Yes, we're creating a 3D botnet. When the Terminators get made, hopefully they'll get made on machines like this. Okay, so at this point, what I'd like to do is I'd like to open it up for anybody who's got any questions. I'm going to stop the screen share at the moment. And basically, if you have any questions, I am more than happy to go through and answer some of them. One of the things that we can do with this platform, and this is an appeal for anybody who is a 3D printer manufacturer. We would love to work with you and get it so there are auto ejection technologies on your machine. We've developed this in-house, and it's works pretty reliably. So we'd love to have other manufacturers producing printers which have this technology. The other thing is that if you're a 3D printer manufacturer who already has 3D printers with automatic ejection capabilities, we would love to work with you and hook you up to our cloud software. And basically, anybody can hook up their 3D printer into our cloud It's pretty easy. We have it set up so that you can use a Raspberry Pi. We have a custom, basically, image of the Raspberry Pi that you just flash on to it, and you have the G-code client, which retrieves the jobs automatically from the cloud and automatically feeds the images back as far as taking pictures while the print is going on and providing that last picture, which gets provided in the email that goes out to the person when their job's complete. So basically, any 3D printer, including ones that don't have automatic part ejection, can be used in this workflow. We also have the option of moderation. So if you are a school and you got 3D printers and you want to have your students 3D printing to them, a lot of times you're going to want to make sure that kids aren't just going and printing out terrible things. And I think everybody has experienced this kind of stuff. If you've ever had anything on the internet, people will go and post things that you probably don't want. Now, over at the Makerspace, we don't care so much, right? Print out whatever kind of weird shaped things you want. But if you're in a school, you certainly do not want the kids printing out weird stuff. So getting a peek at that first, and then going and being able to moderate and say yes or no, and also having the name of the student who wanted to print the object is kind of nice. You might have to have a little talk with them. If anybody's got any questions, please toss them into the chat. I would love to answer some questions. So this was a part that I just 3D printed on there, and basically whenever the part is printed, at least with the slicing profiles that we use, we print it out on top of a raft. And the way our raft works is when it ejects, the raft gets hit by the ejection surface rather than the actual object itself. So when you print it out, you're not going to end up damaging your 3D print with the nice automatic ejection system. So currently the model that we're using for this is a local pickup model. The idea being that a makerspace or a library or maybe even a computer shop, whoever has a 3D printer and some kind of a public-facing business or facility, you can make your printers available. I got somebody coming in the door here, so I gotta put this thing on. Okay. So yeah, basically, so as far as failed prints go, if a print fails, the user gets an email that tells them that their print completed. And if you get a picture and it shows that the print failed, right, you're able to report that. And depending on how your organization's set up, it'll either restart the print automatically or it will go to a moderator who checks to make sure that the object actually failed. The local pickup model is what we're using currently. But if somebody wanted to do a mail order thing, we could potentially support that. We might just have to add a little bit more for figuring out shipping costs and whatnot. The nice thing is with the failed prints, because you get an email that shows you how your part came out, a lot of that quality control actually can happen by the end user and not the 3D printer administrator. Hey, it's the 3D printing professor. I still owe him a 3D printer. Okay, so yeah, if anybody's got any questions, feel free to toss them out here. I am definitely ready to answer some questions. Um, the CAD software is a particularly fun portion of this package. There's not a lot of online CAD software that is fully parametric and really nice like that. You have Onshape, which is kind of expensive if you want to keep your parts private. And there's some other kinds of issues with Onshape as far as never being able to really get your data out of the system. So yeah, there's and then you have Fusion 360, which currently you have to like install stuff on your computer, and then you're really locked in with their system. So you know, there's a lot of nice stuff going on with this. Yeah, I got to make sure that it's going to be a good one when I get it sent out to you there. Okay, so anybody else got any questions? I can go and I can do a little bit of demo on the CAD stuff here for a bit, and I'll just have to try to keep an eye on the questions and switch back and forth every now and then. So yeah, the way the CAD software is, it's really nice because you can use either parts that you've uploaded just from wherever you want. Like for example, this little guy. This is some kind of a little backhoe model, which is being used in a like a little egg kind of a thing. And I think I have this added to an assembly with that egg. Let me go and see where used. Okay, so this right here is my egg assembly. And if I open that up, my egg assembly contains both the egg and the little backhoe here. So if I wanted to, I can actually order that whole little assembly. And in this particular case, there we are. Now I have these two items. It tells me how much material and stuff it's going to use. And if I hit approve order, now that's all just waiting in the queue. The egg butler. As far as the system goes, what kind of a printer do you have? Do you have a Rostock Max with the automatic bed leveling head? While I'm waiting for that answer there. Yeah, as far as the software goes, you can hook up your own regular good old-fashioned 3D printers to it. We do provide a GitHub repository which has the client software in it. Basically, the client software runs on the Raspberry Pi. It fetches the job from the web server, and it goes and it starts the print automatically. And you can have it set up so that at the end of the print, it doesn't go and start up the next one. You can have it set up so that it hangs out and waits for somebody to press a button that's connected to the Raspberry Pi. And that basically allows you to automate your existing regular 3D printers. You know, we did this on the mini deltas. The problem with the mini deltas is they're just not the highest quality machines. We were doing that for a while, and we had good success running them. The problem is that as soon as the nozzle jammed once, you basically had to go and tear down the whole head on the printer, and it was just not fun. Yeah, absolutely. I'll do another little demo here. Earlier, what I did was I designed this knob. This right here is basically a little knob that somebody might use. Let's see here. It's taking a second to load. Oh, there we are. Okay. Basically, this knob was something I just designed in the system. But I can basically, I'll start a little thing. I'll draw a little house for you there. So I'm going to create a new part, and I'm going to call this house. And I'm going to set this to being JSketcher as far as the 3D modeling method that we'll use. And if I go over here to editor, we'll give it a second to load. Keep in mind, I am doing all of this work from a Chromebook here. This is not a Windows laptop. This is just a regular good old-fashioned Chromebook, and I am running everything from inside the web browser. There is nothing native running here. Okay, so basically what I could do is I can start and I can sketch something here. So I have to start off with a plane first. So I'm going to click the plane command, and it's going to create me a plane. I can pick where I want that plane to be. I'm just going to stick with it being on the default location. Actually, you know what? I'm going to do this one because I want my house to be oriented properly. You know what? I'll put it back here. That'll be fine. So I'm going to go and sketch my house. Now, the way I'm going to do this is I'm going to go and draw in a rectangle real quick. So I'm going to draw that in. I'm going to go and set some dimensions on it. So I'm going to set this up as, I don't know, let's say 3 centimeters. So it's going to be 30 millimeters. I'm going to set this up as, let's just say 40 millimeters. And I'm going to kind of locate that over here. Okay. So now I have that. Maybe I want to put a little pitched roof on here. So I'm going to go and draw a little pitched roof there. And what I can do is actually I can set an angle on here. So let's go and set an angle. So I'm going to set this as a 100-degree angle. And now you'll notice that the angle stays the same. And if I were to do something like this, I can set a distance between the peak of the roof and this line. So let's just set that to maybe 25 millimeters. There we are. You know what? I think that might be that might be too far, but that's okay. And the last thing I'm going to do is I'm going to take this line and I'm going to convert it into a reference line. And basically what that means is that the line can be used in the sketch for drawing things, but it doesn't actually get used for the resulting extrude. So I'm going to hit the little check mark here to say that I'm done with that sketch and I'm back out in the 3D world. And I can do an extrude. Now, if I extrude this 50 millimeters, that's cool. I can just do that and hit OK. And there we are. I have my nice little house. Give me a second here. I just got to grab my power adapter. I'm using it to charge my phone at the moment. So, Let's see where I can plug in. So yeah, this is legit a Chromebook. Okay, there we are. So now let's just say I wanted to go and put a little chimney on this house. If I go and I click on, you know what? Let's click on the bottom surface here because it'll be easier to do that. Do it this way. If I go and I sketch on there, what I can do is I can draw a little rectangle to use as a chimney. So I'm going to draw a little rectangle like that. And something else I can do is I can go and constrain this onto location. So I'm going to constrain that onto that line. So I'm going to take that point and that line, and I'm going to tell them that I have a point on line there. I'll give it a dimension from here to there. So I'm going to call that 8 millimeters. I'm going to set this to be equal to each other. So right there, now I have a rectangle, a square. And I'm going to just define the length of this one right here. And I'm going to say, 10 millimeters. There we are. So there's the start of my little chimney. And I'm going to hit this little check mark here to finish my sketch. And I'm going to extrude that. And that seems like it's going the wrong direction. I'm going to flip it the other direction. And we want the chimney to extend a little bit beyond the top of our house. So I'm going to set it. I can either just type in a number here, or I can use my little scroll wheel to adjust the number and hit OK. So there we are. We have a simple little house that we designed real quick. And if I hit save, now it's stored. Now let's just say I don't like the size of this chimney. The size of this chimney sucks. I really don't like it. So maybe I go in here and I edit that sketch again, and I go and I change some of the numbers. So first off, let's change how far the chimney is from the side of the house. So I'm going to set this maybe to 13 millimeters and hit OK. And you see how it moved over there a little bit? I'm going to go and update that again. Let's set that to 18 millimeters. So there it is. It moved quite a bit. And maybe I want to go and change the size of something. Okay, here we are. Let me actually just go and save that real quick and hit OK there. And notice how our chimney went and moved exactly how we wanted it to. And I'm just going to go and save that real quick and go back over here to my part details. Now, oh no, it looks like that part is in the wrong orientation for printing. Maybe I want to go and rotate it. So now I can come in here into my X, Y, or Z rotation and hit save. Let's see. There we are. So that looks like it's oriented correctly for printing. And it tells me some details about it. So it tells me how big my print is, and that's data that the printer uses to figure out whether it'll fit on the print bed. We have our material quantity that it's going to use, and that's an approximation. You could set your infill percentage here. Like if I go and I bump this up to, let's just say about 50% there. I'm going to hit save, and this material quantity is going to update there. So you can see right there that we're going to use more material. I'm going to set this back down to 5% so that I don't go and waste a bunch of material. Before I actually print, it's always a good idea to take a peek and see what kind of G-code is going to be produced. So this right here is a preview of the G-code that's going to get produced here. Now this is going to take a little while to load, unfortunately. It does all the rendering on the client side, and since I'm doing a web stream off of a Chromebook, my all of my rendering stuff is kind of getting slowed down because it's doing all the transcoding to send the video stream out to the internet. I'm actually going to go do something here. I'm going to set this to be half size, which should make it a lot quicker quicker for me to be able to render this out. There we are. This should be zippier. Well, I guess not that much zippier, but zippier enough. You know what? I'm going to make it even smaller, just so that I don't have to wait so long. 0.25. There we are. That's a lot smaller. Most of the time, to look at a G-code preview, you would only want to do this if you were importing a part from outside that wasn't designed in the system. So, for example, right here, this is our little house here. You can see that it's going to get printed. It has a little chimney there and all that. So now that I got that made, I can hit Create Order, and I can pick the location I want to send it to and basically hit this button to create the order. It's going to ask me whether this is really what I want to do, and it's going to present me with a price if my organization is set up for charging for it. And since it's not, it's okay. But I'm going to hit Approve Order, and now it is waiting in the queue. And I've just loaded up the queue with with a bunch of junk. Right here, this is actually the live print that's going on. This is the knob I designed earlier. And you can see that we're at around 50% on it being made so far. If I hit refresh, scroll back down here, now we're at 52, so that's kind of nice. Oh, shoot. Did I just do all that and not have my screen showing? I apologize. I just went through and designed that part, and I wasn't showing my screen. Oh, my. I feel like an idiot. That's okay. I'll show the screen and do that part real quick. So this right here is that little house that the 3D printing professor wanted to see get designed. I'm just giving it a second to load up here. So right there is the house. I'm going to actually go and delete everything here. And start from scratch. Give me a second here. Okay, so in order to start off doing a model, I'm going to tell it that I want to add a plane, and it's going to ask me where I want to have that plane. I can pick any of these and hit OK. And now what I can do is I can start designing my object. So if I click on that plane, it highlights, and I can do a sketch. And the way that sketching works is I have these tools here. So I'm going to use the rectangle tool real quick, and I'm going to go and draw like a rectangle here. And I can go and set some dimensions on it. So maybe I want to set this to, let's just say 80 millimeters. I'll set this one to 35 millimeters. And I'll do some more stuff here. I'll put the little peak for the roof in. So we can do that. You know what I'm actually going to do? I'm going to set this up so that this roof peak has some dimensions on it. So I'm going to go and give this a dimension from the side of the house here. So I'm going to set a dimension there, and I'm going to set that to 30 millimeters. I'm going to set the height of the peak of the roof from this line. So I'm going to set a dimension on that of, let's just say, 40 millimeters. And I'll take this point and I'll put a fix on it so that it doesn't move. So yeah, there we are. We have our sketch. Now, if I hit the little checkbox here, it finishes the sketch, and then I can do something like extrude on it. Now, in this particular case, I'm getting this extra piece of geometry here. So I'm actually going to go back into that sketch, and I'm going to tell that piece of geometry that that is only reference. So you can basically see there that that is a piece of reference geometry. You can still use it for developing your sketch, but it's ignored for the purposes of the extrude. So in this particular case, we're going to do that extrude. I'm going to set the value. You know what? That's fine. That's fine for my length there. And I'm going to hit OK. So now I have my little kind of house-looking thing. Now let's just say I wanted to add a chimney to this. If I wanted to go to do that, I could pick like this bottom face of the house here. I can sketch on there. And I can draw something like my little chimney. So if I go and draw a rectangle here, there's my rectangle. I'm going to use this for producing the chimney. Let's go and set these two lines to be equal in length. So now I have a perfect square. And I'm going to go and set a distance on this, and I'm going to set that to, let's just say 12 millimeters. So now I got my reasonably sized chimney. Now, if I pick this line and I pick that point there, I can tell that point to always be on that line. So now this is constrained to that line. And if I wanted to, I can go and set a distance like from the edge there. So I'm just going to go and do a distance there and set that to, I don't know, 20 millimeters. And now if I hit this little checkbox, that sketch is ready to be extruded. So if I do an extrude, so it looks like the extrude's going the wrong direction there. So if I hit this little flip right there, it'll flip the direction. And if I use my scroll wheel, I can adjust the distance that it's going to go. So right there, I guess that looks like a reasonable chimney. And I can hit OK. There we are. So now I've designed my my little house with a chimney. I'm going to go and hit save. And now it's saved to the cloud. If I come over here, I can see, oh no, I didn't orient it properly. So maybe I want to go and orient it properly and save that. Let's see here. Oh, now it's entirely upside down. Let's do 180 here. So now I have it oriented properly for printing. I can hit create order, and I can pick my location I want to send it to. So these are organizations that I have access to. If I hit create order, it brings me into the order screen where it would present me with any prices if there were any. At this particular organization, we don't have any prices set for the members because it's basically free for the members, but we can approve the order. And now that the order is approved, it's just sitting in the queue, and it will get created and ejected whenever that is done. Construction 3D. We would love to be able to support black belt style devices. Unfortunately, I don't have any black belt printers at the moment to experiment with. We would have to do some stuff because the slicing software for that is significantly different, and I believe that a lot of the support generation is done on the UI side and isn't something that we can really automate via the command line just yet. I am hopeful that at some point somebody will let me borrow one of the belt-based machines, and we can go through and do the integration for that. That would be really nice. As to the Egg Butler, the CAD software that's part of the system is it's free as far as the cloud goes. The idea is that if you were to print it to a public printing location, you would be paying that public printing location to print it for you, which allows us to have the credit card processing fee. That's what allows us to kind of stay in business. Okay. Hopefully that little demo of the house came out okay for you, 3D printing professor. If there's any other questions, I can certainly go and try to answer them. I would really, really, really love to get my hands on on one of the 45-degree belt printers. And if somebody is starting to manufacture those, if somebody's starting a business for those, if you wanted to send us a printer and have us do the software integration for it, we would love to do that, to figure all that out and get it set up. Let's see. I've got 1, 2, 3. There's a lot. There's probably around 10 printers on the network right now. We have this printer here, which is at the Spark Makerspace, which is my home makerspace. We have one at the Bill Library in Ledyard, Connecticut. We have one at one of the co-founders' house. He's been using that for doing calibration and printing out a whole bunch of D&D action figure kind of things. We also, I have a whole bunch over at my house, which, I just got piles of 3D printers everywhere. But, we've been experimenting with some other ones. There's somebody who's been working on a Polar kind of a 3D printer, which has an auto-ejector on it. So we've been messing around with that. So yeah, there's a lot of different, there's a whole bunch of different 3D printers that are on here. If anybody has a 3D print farm or is thinking about starting one, the beauty of this software really is that you can fully automate your system with the minimal of human interaction with the printers. You'll note that I never actually go and touch the machine here at all for removing the prints when they're done. The prints just pop off automatically and go on to the next one. Okay. Anybody else got any questions? I would love to, if somebody has a 3D printer and a Raspberry Pi and maybe a couple push buttons, I would love to walk you through how to get your 3D printer hooked up. I haven't done too much as far as putting together that kind of documentation. It's kind of highly technical at the moment, but it's easy enough that you can get it going. That's the goal, especially during COVID-19, right? So the library that has one of our 3D printers, what they've been doing is they've actually had people 3D printing all sorts of like templates and stuff for basically like making masks and stuff like that. And there's been an awful lot of stuff going on with them. And basically what they're doing is, since the library is still staffed and they're still picking up the phones and doing that kind of phone service stuff, they've been able to do some stuff where they put parts outside for people to go and pick them up. And nobody's actually coming into the library. Yeah, the software for the client, which will run on the Raspberry Pis, is available on GitHub. And basically, you can either download the software onto a Raspbian image and then install all the packages, or you can download our pre-built image, which has everything all set up for you. It makes it pretty easy. One of the nice things that we did is we made it so that when you boot up the Raspberry Pi using the image that we've put together. Um, it listens for a particular GPIO pin to be pressed. And if you press that, it switches the Raspberry Pi into a Wi-Fi access point mode, which allows you to get into it and configure the Wi-Fi settings without actually having to do weird stuff on the SD card. So you don't have to go and try copying files over or go through any kind of convoluted Wi-Fi config. You just burn the SD card image and boot up the Raspberry Pi. And then if you press a button hooked up to a particular GPIO pin, it switches over into an access point mode, which you can just connect to from your phone or whatever and give it your Wi-Fi credentials to get it hooked up to your network. Okay. If we got any more questions, I can go through and answer them now. Otherwise, I'm probably going to be hopping off here in a couple minutes. It's been a real pleasure being able to talk about this, and I hope that some folks are interested and maybe contact me afterwards if you want to get something like this set up on your own printers. We're very keen on helping people actually get this hooked up with their own hardware, and we're also keen on helping manufacturers of 3D printers if they want to add in our automatic ejection system, and need to know how to do that and get it all set up. We are looking to help out and partner with manufacturers if they want to have this kind of technology. Yeah, it's been good. Okay, I'm going to sign off now. Thanks, everybody.